So let's look at some of the other issues that I heard pop up in the conversation. Sarah observed that the arms would go down during transit if no operator power is applied. The arms would actually lower down as they go, and I think that's been something that's gone on from the very beginning. Now, I think according to number one there, I think of course the operator could keep it up by moving the stick and applying some power. That's probably what you do right now. If it's an issue, you might try adding a line of code in the init portion of the teleops, and there's a under the motor area, there's and let me show it to you here very quickly. There's a line down here that says set the power, in this particular case the motor is called rehex, but whatever the motor is, to zero power behavior. To zero power behavior is break. In that particular case, if it goes to zero power, then the motor will go into brake mode and try to hold that position. So a simple line like that added in it portion may be able to solve it. The reason you're having this problem, of course, is the weight plus the superstructure weight out there times its arm length is greater than the gear friction and motor friction times the little purple pulley and its radius. So that's the reason why it's happening. The other way you can, and I certainly would say try that software fix first. That may just make the whole problem go away. The last thing you could probably do is just to move the cord further back on the puller arm, and that would lower the gear ratio, and you might need to actually increase the power to make up for the speed loss. So there's what you can do on that particular one. Let's see, what else do we have? Okay, how about Michelle indicated that the let me move that out of the way there for you. There we go. So Michelle indicated you might be looking at direct drive of the lifter for the next robot. I think it's an interesting idea, and we have some new discoveries by building the mule that may help to see whether this actually will work or not. The challenge, you probably know, is does the motor have enough torque, and not only enough torque, but enough torque and control so that you can move the glyph with the kind of the control that you want. And the only way to find that out is to actually do it. So what we've learned since we started building Mule 1 is that at least I found that the motors have considerable torque. And in some of my experimentation shows that, oh yeah, this thing might be able to lift this thing all by itself. In fact, I think it will lift it. It's the control issue that may be the problem. The other thing that we've done is we've purchased more motors with encoders. Since the system you have right now, when it hits the bottom, it doesn't require some sort of a limit stop, and so keeps you from getting yourself in a problem. And the only place that really requires any limit stop would be at the top. But since you really never have to go really high, we never have run into that problem. So we kind of eliminated that with that string pull thing. But now that we have some encoders, we have the ability to put software limits in using the encoders. So that's a new tool that we have in our toolbox. And power modulation works. Seems like the motor still has quite a bit of torque. You may be close enough to try this, and so if not, I'm a big advocate of experiments. You probably know that. Experimentation is pretty revealing, shall we say. Physics has a unique way of actually telling you whether things work or not. So here's a very quick setup that you can make, and this really wouldn't take very long. Use a motor with the encoder, kind of lock it down to a table or a clamp, or screw it to a piece of plywood or something like that. Put an arm on there that represents the length of the arm that you have now, and maybe hang a glyph, and then put some more components out there, because you have some superstructure with servos and things like that sitting on the top of that. And then go in and set some encoder limits, because you don't want this thing swinging around. Remember, that motor turns at 2.5 cycles per second. So in 1 second, that arm in theory would go around 2.5 times. So you've got some serious control that you're going to have to work on here. So set the encoder limits, number 1 up there under control. Start with power very low, so you don't make sure this thing spins around and hits something. and make sure that hopefully will make sure that the encoder limits are working. And then you can certainly increase the power as needed. At really low power, it may not have enough power to actually lift it. So creep up on it. The worst case scenario is when the glyph is strayed out from it, because gravity, the force of gravity on the glyph times the arm length has to eat the or equal the torque of the motor times that little bitty radius back there at the shaft. And then you have two different encoder options, on and off. If on works, and on means that you take it under control of the software that's inside the Android FTC phone. That's great if that works. If not, that doesn't mean it won't work. You may have to turn it off. You can actually sample the encoder steps and build in your own limits, and then it gives you a little more control over if you're trying to get the thing to operate with certain nuances around a particular point. One thing which you must absolutely do, or you may be discouraged, is pay very close attention to that connection back at the motor. There's some serious torque stresses back there, and you might find if you don't pay attention to that, you may get discouraged that your idea doesn't work. So make sure that is really a strong connection. Okay, so let's see. Is that everything I want to say? Oh, yeah, that's it. So very good. Best of luck to you.